Okay, Brian, we are on number 6 and 7. 6 and 7. How do you tell whether it's a right, acute, or obtuse? Like, I have these sides, 30, 40, and 50.
If they're greater than the third.
You're close.
The two smaller ones are greater than.
How do you know if it's a right? If 3 sides make a right triangle, how do you know if it's a right triangle?
If they.
Pythagorean theorem. A squared, B squared, C squared, right? If A squared plus B squared is equal to C squared, it is a right triangle, right? Okay. But let's say A squared plus B squared, let's say C squared is even bigger than A squared plus B squared. Let's say like C squared is huge in comparison to these two. These two added together, C squared is still bigger than that. What kind of triangle is that going to be? Obtuse, because I have one side that's really, really huge. Obtuse, okay? And then let's say A squared plus B squared, and then I have C squared, and C squared is still small in comparison to A squared plus B squared. Like this is bigger than C squared. Then it's going to be acute, because I have 3 sides that are like all kind of ish the same, okay? So if my biggest side is still fairly small, it's going to be acute. If my biggest side is really big, then he's going to be obtuse. Got it? All right. So which side is side C, by the way, on number 6? 50. Is it always the third one? No, it's the biggest side. So be careful because sometimes they might put them not in order for you. So I want to see if 30 squared plus 40 squared is equal to 50 squared. I don't know. Let's see. 30 squared is 900. 40 squared is 1600. Do you know how to do these without using a calculator? Yes. What's 50 squared? 2500, right? 5 squared is 25. And 2500 is equal to 2500. I knew that before actually putting him in there because this is a 345. If you divide by 10, it's a 345. So he is a right triangle. If you knew that to begin with, then you didn't have to do all the work, right? It's just a scale factor of 10, right? Just multiply everything by 10. So he is a right triangle. All right, this one, which side is side C? 40. It's not always the last one, but in this case, it's the biggest one, 40. So 40 squared. Let's see, 20 squared plus 30 squared. What is that in relationship to 40 squared? 20 squared is 400. 30 squared is 900. Is something in relationship to 1600. 400 plus 900 is 1300. Okay, so my biggest side, is my biggest side a big side or is my biggest side a small side? Is a big side, right? It's still bigger than these two added together. So my biggest side is a big side, which means he is obtuse. You see how that works? If your biggest side is a really big side, then he's obtuse. If your biggest side is still fairly small, he's acute. Got it? Good, good? Okay, now you can take some shortcuts here. What are they wanting you to do on number 4? Find x, right? How do we do that?
9 plus 9
They do the Pythagorean theorem, right? Okay, all right, so let's do the Pythagorean theorem. 3 squared plus 3 squared equals x squared. 3 squared is 9. 9 plus 9 is 18. So this guy is the square root of 18, or whatever that is. 4.24. What kind of triangle is this, by the way? A right triangle?
It's a 45.
He is a 45, 45, 90 triangle. How do you know that?
3 and 3.
3 and 3, right? So this guy would be 3 square roots of 2. Did you know 3 square roots of 2 is the same thing as the square root of 18? Or 4.24, right? So that's another way of getting that, right? However you want to think of it. 5. You're solving for using the Pythagorean theorem. Which side is side C?
15.
15. So 9 squared plus x squared equals 15 squared. 9 squared is 81. Do you know what 15 squared is?
225.
225. Okay, minus 81, and that is 144. And the square root of 144 is 12. Guess what? You could have gotten that by 9 divided by 3 is 3. 15 divided by 3 is 5. So that means this is my 4 side, but I've got to multiply by 3 to get him back to the scale factor, so he is 12, right? So you could have gotten him that way also, using a Pythagorean triple, 3, 4, 5. Good? 3, 4, 5 is one of the ones I told you to memorize. What was the other one? 5, 12, 13. Those are the ones that you'll see the most. All right. How do I solve number 3, x, y, and z? How do we do that? Remember? This was a long time ago. We did these outside, I think. When we went outside. Sat on the sidewalk? What? Yeah, draw the 3. So small. I always face them the same direction, so I do it like a little L and a slant. right? Medium. It just helps me be able to see like which sides go with which sides better. Large side. I'm setting up similar triangles, by the way. That's what these are called, similar triangles. Okay? All right, draw your 3 and then we'll label them. Small, medium, large. Okay? All right, so for your small one, which one is the short side?
2.
2, what's the tall side?
X.
X, what's the slant side?
Y.
Y. Okay, medium, short side.
X.
Tall side.
5.
5, slant side.
Z.
Z. Large, short side.
Y.
Y, tall side.
Z.
Z, slant side.
5. Or, no, 7.
7. 7. You add the 2 and the 5 together. Got it?
Check 2.
Okay. Did you get all that written down? Or is that okay?
Check 2.
All right. You don't necessarily have to solve these in order, but I think we're going to. Because I don't think you have to solve them in a different order. So let's just do X first. I see X here and I see X here. Which other 2 sides do I have to use? I'm using the tall side and the short side. So I got to use tall side and short side, tall side and short side. 5 and 2. Okay, let's set up a proportion. Something over something equals something over something.
X over 5 equals 2 over, or no.
That's fine.
Oh.
That'll work. X over 5 equals 2 over X. He's going left to right, yeah? You could have gone top to bottom, so X over 2 equals 5 over X, whichever way. X times X makes this X squared. 5 times 2 is 10. And then we take the square root. Square root of 10 is 2? 3.2? 3.2. They say round to the nearest tenth, which is 1 decimal place, so 3.2. Yep. Okay. I'm going to erase my little bubble things here. We're going to go Y's next. Nope. Redo. Okay, Y. I have a Y here and I have a Y here, so we're going to ignore the middle triangle. What other 2 things do I need to include? Yep. Can you do Y over 7 equals 2 over Y? Sure. I usually go Y over 2 equals 7 over Y just because, like, they're top and bottom. But you can go Y over 7 equals 2 over Y. That's fine. Yeah, let's do it. Y over 7 equals 2 over Y. Just as long as you're going the same direction for both of them. So Y squared equals 14 and take the square root. And that is also 3 point something. 3.7. Okay. All right, now we got to do Z. Okay. All right, Z. I have a Z here and a Z here, so we're going to ignore the small one.
C over 7.
We've got to use 5 and 7. Is that true?
Mm-hmm.
Okay, Z over what?
7.
Okay, equals 5 over Z. Ooh. Okay, I'm going to zoom in over here. 5 over Z. 5 times 7 is 35, and Z times Z is Z squared. And then I take the square root, which is a little less than 6. 5.9? Perfect. Do you guys, like, guesstimate that in your brains? Like the square root of 35, just to make sure you typed it in right, like into your calculator. I know it should be 5 point something, so I'm expecting the answer to be 5 point something, right? No? Okay. That way I know if, like, I get something that's not 5 point something, then I know I typed it in wrong, you know?
I mean, if I think it's wrong, I'll do that, but if I just see that.
Okay, sure. X, Y, Z. Okay, geometric mean. Okay, regular mean is adding them up and dividing by 2, right? But geometric mean is different. Like, if I add, like on number 2, if I add 4 and 6 together, that's 10. 10 divided by 2 is 5. 5 should be the regular mean, or the regular average, right? The average is 5. But that's not geometric mean. They ask for geometric mean. What's that mean? This is a geometric mean. This is the geometric mean of 7 and 2. This is the geometric mean of 5 and 2. This is the geometric mean of 7 and 5, right? So it's like 4 over x equals x over 6, right?
So then do we just
X times x is x squared. 4 times 6 is 24, and the geometric mean is whatever the square root of 24 is.
4.8. Is it rounded to the 10th?
Yeah,
4.9.
I think. Oh, it doesn't say. It doesn't say. We'll go with 10th. What?
4.9.
4.9. Perfect. So, if we were just to do the regular mean, it would be 5, but 4.9 is the geometric mean. Okay? Now, I don't like the answer to number 1. What's the regular mean for number 1?
4.
Yeah, the regular average would be 4, right? Okay, this would be like 4 over x equals x over 4, right? X squared equals 16, and we take the square root. So the only time that your geometric mean and your regular mean are the same number is if you're taking the geometric mean of the same number, right? Okay, otherwise they will not be the same number. Good? Woo! Okay, all right. Are we happy? You're killing me. Yes, I will let you. They asked me that this morning. I am going to be gone for this class period tomorrow. I just found out that I have to go observe Mrs. White teaching, so I won't be in here. So, note card, that guy, sure. We'll make it easy on him. Okay? All right, there you go. So somebody make sure that Brian has this done, right? Has it filled in?